Okay, going on to solving inequalities. This lesson is basically a recap, I hope, for most of you. It involves going through some exercises on transom. The first bit is basically the exercise at level 5 on the test that you're given. Then after that we've got some stuff on level 6. Level 7, and I think we've even got one level 8 question, level 7. 6. That's level 6 as well. Level 7 question is down below. Okay, so that's the level 7 type stuff. I intend to just whiz through these quite quickly with some middle explanation. If you need help, please ask. Okay, so let's go back to the first one, and what we're looking for is all numbers that are less than 2. So clearly that's 4, minus 4, minus 3, minus 2, 1, 0 and 1. But it doesn't say anything about these being only integers. It also could be the 0.5, 0.9. It could be any number up to 1.9999999999999999999. So we need to be able to represent every single number less than. That's quite simple with a straight line, with an arrow. And the significant point is number 2. And if we leave this open, we are saying, but not 2. That's an open hole. Okay. If we go to the other one, x is greater than or equal to minus 1, so of course we want the 4, the 3, the 2, the 1, the 0. Because of the line underneath, we also want the minus 1. So again, we've got a line going all the way, showing keep going that way. And we would like, the value 1 is important, we want to include it. So we would now include the 1. Now, some of you might have Russian tutors. They may talk about x belongs to a set. And if it's less than, we're going from minus infinity to 2. And infinity ones, you can never be equal to infinity, so you use a round bracket for not including. And on the right-hand side, we don't want to go up to 2, so we're not including the 2 on that end. If we come to this one, x is a member of the set of values from minus 1 all the way to infinity. So we don't include infinity, but to include a number, you use a square bracket. Okay. You never include infinities. Okay. Let's go for the next one. We've got minus 2 is a significant value. 3 is a significant value. We want to include at minus 2, so we fill it up. And x is between these two numbers, so we connect them. There is another example that I'd like to do that's not on the transom. I'll put that in here. So let's just finish this example off and then I'll do another one. So representing x belongs to a set of values including minus 2 to the value 3, but not including the 3. Okay, so a square bracket for including. You're more likely to see this in Russian books. But this is international. It is valid. Okay. The one other thing I'd like to show you is it's related to this more than anything else. you can sometimes get inequalities where, especially quadratic inequalities, where we've got two conditions, and we've got x is less than -2 and x is greater than 3. If I place that on my graph, it's not pasting it where, it's pasting it randomly. Come on, one more. There we go. So I'll just put that into my line, drag that over to here. So let's look at what this represents as on a number line. We've got -2 is important, 3 is important. Neither of them are included, but we're saying x is smaller than -2 and x is bigger than 3. Well, those two things can't be true. So this is actually an or statement. It's one or the other. This one is an and. X is between both of those situations. So we've got this or statement. How do we represent it in the sets, or the set notation? You actually do a union of two sets of numbers, one describing the first group, we can't include -infinity, to -2, not including it, and from 3 to infinity. And to say that these two are being added together, we use a union note. That means put together. You may recognise that from Venn diagrams.